quadratic function f of x is graphed below. Solve for the addition of every single integers of x that satisfies f of x equal to 7. Well, what is function f first? So for the function, it is something that requires a specific input. And with that input, there will going to be a function created. And according to that function, and according to the equation that the function contains, there will going to be a specific output. And when we notate the function in a basic terms, we use input as x values, output as y values, or f of x. So this is what the function means. If we think about our normal function, it will going to be the f of x or y. But in this case, the function will going to be f of x. So we can clearly see that this is different with the normal function that we saw usually. And we can see that this will going to be a composite function. So if you write it down, this will going to be a composite function. The definition of a composite function is that they include two functions in one function, which means f of x. So there is a f of x function, but then this became the x values of f. If you just think about f of x, the f of x is a y value, which will going to be the output of our function, but the output of our function became the x value of our new function f. So we can essentially see that it can be a composite function where it contains a function inside or as the x value. So our question is basically trying to find the x integers. And integers, if you think about the definition of the integers, it contains negative and both positive natural numbers. And we can see that natural numbers is a number that doesn't count the fractions or the decimals. So this will going to be just numbers, which we call it as integers, that can be either negative or a positive value. So if you write our coordinates that are given that satisfy the just f of x6, not a whole f of x. So at first, if you input the value as 6 as our x value, we get an output of our function which will going to be 6. So that satisfies 6 and then 6. And for the second one, so we can make it in an order. So for the second one will going to be the value of the negative 2, because if you input negative 2, they gave us the output of the function which will going to be 6. And they're all the functions, they're all the coordinates. So this will going to be the coordinates that satisfy our f of x, just f of x function. So that satisfies just f of x is equal to 6. For the f of x, But yet this f of x, which is essentially going to be the y value, will going to be the x values or the x inputs of our function f of f of x. This is what the f of x means. If you just think about the f of x, it is the output of a function, but for that output, this whole composite function takes that output as its input. So that means if we input the 6 into our original function f of x, it gives us 6 also. So we can actually prove it. So if we input the 6 value, it will going to be the x value. It will going to be f of, but our output of our function will going to be the y value of our coordinate. So if you think about the y value of our coordinate 6, 6, the y value will going to be 6. So we can input as 6, which will going to be the output of our f of x function, but will going to be the input of f of x function. So f of 6, we count 6 as the input of our new composite function. So if you input 6, they still give us our output of our function as 6. So we can see that this still going to give us the output, which will going to be 6. So this first one, which will going to be 6, 6, satisfied. So if you prove the second one, which will going to be negative 2, 6, so our original function was f of x. So if you write our coordinate down, our coordinate was negative 2, 6. But if you just think about the inside the parenthesis, which will going to be f of x, it is the output of our function, which will going to be f of x. So our output of our function is essentially going to be the y value of our coordinate, which will going to be 6. So if we input 6 as our f of x, it will going to be f of 6. And our output of our function just became the input of our new composite function f. So if we input the 6, it still gives us this 6. So our output of our function will still going to be 6. So our negative 2, 6 also satisfy our function. Trying to tell us to find every single integers of x values, not our y values. So our answer for this question will going to be negative 2 and then 6. But if you look at our function, there is one more coordinate, because from our function f of x, if we input the value of 2, so if you input value of 2, which will going to be just f of x inside the parenthesis, x value, it will going to be f of 2. And then f of 2, if you think about f of 2, well, it's actually going to be, so we can count our whole function f of 2 into our output of our function. If we follow our x values, it gives us output, which we're going to be negative 2. But we are only counting f of 2 as negative 2, which means if we write our whole new function down, we need to calculate. We're going to be f of negative 2. And our output of our function, which was negative 2, from our f of 2, this became the input of our new function. And this is what the composite function works. So f of negative 2, same thing with negative 2, 6, because input will going to be same thing with the x values, and negative 2 will also going to be the x values. So this will going to be the 6, which satisfy our every single integers of x that satisfy f of x is equal to 6. So our total answer will going to be -2 and 6 and then 2. So these are all the x values that satisfy our composite function. But for our question, they told us to find the addition of every single integers of x. So the addition of x that satisfy our function will going to be -2 plus 6 plus 2. -2 and the plus 2 we're going to cancel out as 0. We're going to get an output or the answer as 6. So our answer of this question we're going to be positive 6. The only thing that we have to memorize or remember in our function f of x, at first we care about the inside the parenthesis, which we're going to be f of x, and if we input the x values inside our parenthesis, that will going to be input, and the output of our function will going to come out of from our f of x. But then the output of our function will soon turn into input of our function from our f of x. So we can see that from the big composite f function, the inside the f of x will going to become whatever it turns into will going to become the input of our function.